There are many ways to read XML files in Java. There are many programming interfaces and packages available. They're known by their acronyms. There's JDOM and Stacks and SACS. But the most venerable, the one that's been around the longest, is known as DOM, or Document Object Model. The Document Object Model approach to reading XML isn't the most fun or the most concise, but it's the most deeply embedded in the Java libraries, and so that's the version I'm going to show you here. I'm not going to show you everything about DOM. That's something that would require a whole separate course. But I'll introduce you to some of the most critical classes that are available. And as with the classes that I've shown you to read files from the local file system and from the network, these are classes that are available in the core Java class library. As with the previous video, I'm going to be working with this XML feed at services.explorecalifornia.org/rss/tours.php. The code I'll show you will work with any RSS feed, because the structure of an RSS file is standardized. So let's start with this empty class. So the first step in reading an XML file is retrieving it. And when you're working in the document object model world, your first goal is to create a document object. It takes a few classes to get there. I'm working in an empty project named parsexml, and its class readXML, and its empty main method. The first step is to create an instance of a class called Document Builder Factory. I'll type document build and press Control space, and I'll choose the Document Builder Factory class from javax.xml.parsers. And I'll name the variable factory. Now this code's going to get a little bit wide, so I'll maximize my editor, and then I'll press Enter or Return and go to the next line. And the Document Builder Factory class is a class that you instantiate by calling its static method newInstance. So I'll call Document Builder Factory.newInstance. Now I have an instance of that class, and I'm ready to go on to the next step, creating an instance of a class called Document Builder. I'll type in the name of the class, and I'll choose the class from javax.xml.parsers, the same package as the factory class. I'll name this one Builder, and I'll get its reference from factory.newDocumentBuilder. Now I'm ready to create my XML document object. The data type for this will be document. I'll type in the name of the class and press Control space, and I'll make sure that I'm choosing the document class from org.w3c.dom. This document class implements the Document Object Model programming interface as defined by the W3C. It's the same programming interface that you might use in JavaScript and in other programming languages, but it's specifically implemented for Java. I'll name this variable doc, and I'll get its reference by calling the Document Builder class's parse method, like this, builder.parse, and then I'll pass in the URL to the parse method. I'll go back to my browser, I'll copy the URL to the clipboard, I'll return to Eclipse, type in a double quote, paste in the URL, close the string, and close the statement. When you call the parse method, it takes care of the downloading of the file and parsing the document and turning it into a hierarchical set of objects that you can traverse using document object model programming. Once you have the document in memory, the next step is to get the data. You could walk down the XML tree one level at a time, but there's a really great convenience method that's a part of the document class named getElementsByTagName. If you know the tags, that is the element names in your XML file, then you know how to get the data out. So I'm going to create an object which is data typed as node list. In DOM, a node list is kind of like an array. It's an ordered collection of objects. It has its own API, which is a little bit different from an array, as you'll see in a moment. I'll type in node list and press Control space, and choose node list from org.w3c.dom. I'll name the variable list, and I'll populate it using the syntax doc.getElementsByTagName, and I'll pass in the name of an element I'm looking for, title. In RSS, each news item is named an item, and each item element has a sub-element named title. For this exercise, I'm only interested in the titles of the news articles, so that's what I'm retrieving. And now let's find out how many items we got back. I'll output a string, there are, And then here's a way in which the nodeList class is different from an array. With an array, you determine the size of the array with its length property. With the nodeList, you call a getLength method. It looks like this: list.getLength. I pressed Control Space to autocomplete the code there. Then I'll append the string items. I'll save my changes and see if there are any errors. I see one right here that I need to fix. It tells me that there's a syntax error here and I just missed my plus operator. There we go. I'll save that change and see that there are errors from unhandled exceptions. As I've done in earlier exercises, I'll handle that by selecting the code and then surrounding the code with a try-catch block. There are 3 possible exceptions, and Eclipse generates catch blocks for each of them. I'll get rid of the to-do comments to shorten the code, and then I'm ready to save and run the application. And I'm told that there are 27 items. So now the next step is to go get the text value of each title element. In the document object model, each part of the XML file is seen as something called a node, and each node is of a particular type. So for example, let's say that you had an XML node that looked like this, starting with title and ending with title, and then between those tags, some text. In the document object model, that's actually 2 separate nodes, one a parent and one a child. Title is an element node, and the text within it is a text node. And if you know that, then you know how to get the text out from the title. I'm going to create a loop. I'll use a for loop to loop through the nodeList contents. I'll choose iterate over array, and I'm going to keep on looping as long as my counter variable doesn't exceed the length of the nodeList. So I'll change args.length to list.getLength. Within the for loop, I'll get the item in the list. I'm going to data type the item that I'm retrieving as an element. Once again, this is a class of the DOM interface. I'll name the object item, and I'll set its value using casting syntax. I'm going to be retrieving an item from the list. The nodeList will return it as a node, the superclass, but I know it's an element, the subclass. I'll retrieve it by calling the item method and passing in the I counter variable. Finally, I'll output the value within the element. To do this, I'm going to walk down the XML tree from the element node down to its child node, the text node. I know it's the first child of the element, because text nodes always are. So I'll use system.out.println, and I'll output item.getFirstChild, and then from there, I'll call a method called getNodeValue. When you're working with a text node, the getNodeValue method returns the string value. I'll save and run the application, and there's the result: a listing of all the titles from all the items within the RSS feed. Now, if that seems like a lot of code just to get to the titles, you're right. It's more code than is really needed. And if you switched over to one of the third-party libraries for working with XML and Java, such as JDOM, you'd find your code was significantly smaller and easier to work with. But it's important to know what's available in the Java class library. When you're working with XML in the class library that's a part of the SDK, the document object model is always available. It works in all Java development environments: console applications, web applications, mobile applications for Android and BlackBerry, because, as always, it's just Java. There's obviously a lot to learn just about working with the document object model, but you can choose between that approach and the other libraries that are available in the Java community.